Okay, so here's phase 16. So a couple things, guys. If you'll remember from algebra 2, I think they would talk about end behavior. So basically, if you've got a polynomial and the leading term is of the form a, which is some number, times x to an even power, then you're either going to have, so here I am just showing, I'm not showing the entire function, I'm just showing the end behavior way out at positive and negative infinity. So here, if the leading term, that means the term with the highest power of a polynomial, if it is has x to an even power, it's either going to look like this, like its end behavior way out at huge x values, looks like that. So going up to positive infinity, and for the y's, or it looks like this. Okay, that would be if the leading term was negative. If it's x to the odd power, then it would either look like, this or that. And I typed into the calculator, for example, like x squared, that has an even exponent, so that's why, it goes like this at the ends. Okay, so any even power would do the same thing at the ends if the leading term had an even exponent. And then, like x to the third, oh, I want to highlight that and de-highlight that. Okay, so here's x to the third. So way out for big x's, it would look like, like that at the end. So like I did up there. Okay, so that was the end behavior, a little review of end behavior from previous years, if you remember it. Now, the directions are: state the end behavior model of f of x, use the end behavior model to determine the end behavior of f of x. Now note this, guys. If f of x is of the form a polynomial divided by another polynomial, then the end behavior model of f of x, of the whole function, is equal to the end behavior model of the first polynomial over the end behavior model of the second polynomial. All right, so what it says is the end behavior model, if the function looks like this, the end behavior model of the whole thing is this fraction with the end behavior models of the top and bottom taken. All right, so let's find the end behavior model of this. All right, so all right, so this means that the end behavior model of f of x is equal to, guys, for the end behavior of the model of the top, you just take the leading term, which is the one with the highest exponent. So the highest exponent term up top is x, divided by the end behavior model of the polynomial on the bottom. So the leading term here, now the leading term is not necessarily the one that's written first. So you might have to look, like in your practice, you're going to have to look for the highest power term. But down here, the highest power term is 2x squared. Okay, and then, so these x's kind of, yeah, they cancel, so we get just 1 over 2x. So just 1 over 2x. So that's the end behavior model of this original function. And we use it to find, the end behavior. So we're going to use this end behavior model. So I go like this. So use the end behavior model to determine the end behavior. Okay, so this part, guys, we're going to use arrow diagrams for. So end behavior means as x approaches infinity and as x approaches negative infinity. Now, as x approaches infinity, so like think of 100, 1,000, 10,000, 100,000, going in for x. Guys, if we use the original function, that would be like really hard to figure out because there's so many x's. But knowing that the end behavior, the behavior at the infinities of this original function is the same as this, because that's what an end behavior model is. We just use it as a model, not as though it's the actual function, but it models its end behavior. Then, so we're going to use this because this only has one x. So So using 1 over 2, okay, using 1 over 2x, we have this, okay? So as x approaches infinity, y approaches, guys, imagine huge numbers going in for that x. All right, you're gonna get 1 over infinity. So the y's are approaching 0 in both directions. All right, so this is one part of the answer, and that's another part of the answer. Okay, now if the x ended up on top, the y's would be going to infinity, but you have to consider like plus or minus infinity. So pay attention to the signs. All right, let's do this one. All right, so then the end behavior model of this function. All right, leading term on the top is 10x to the third. Leading term on the bottom is 2x to the cubed. Leading term doesn't mean first, it means highest power. All right, it doesn't always come first. And then, guys, we just end up with 5 here. Okay, so using 5 as our function model, as x approaches infinity and as x approaches negative infinity, guys, the end behavior model of this function is a constant function. So this actually means that this one will have a horizontal asymptote, but we could talk about that at another time. So we're just using 5. So x could be 10, 100, 1,000, a million. It could be negative 10, negative 100, negative 1,000, negative a million. This is always going to be 5. Okay. Yeah, so we actually have a horizontal asymptote for that. All right, so there's the end behavior model. So the answers are what I boxed up.